All right, so you want to start with just some basic series?
Yeah.
Or let's do some combination stuff. So this is like what we've done in class. So let's say that I have a 12-volt battery. I have a capacitor. All right, so on this circuit, I want to know all of the.
What's up, Jordan?
Hey, George. So we're going to do a little bit of capacitor circuits. Some of those resistors. All right, so on this circuit, I want to know what are the voltages and the charges on all of them. Right?
Okay.
So the first thing you want to do is to find the equivalent capacitance. And in order to do that, you want to figure out which one is the smallest series or which one is the smallest parallel.
And so we would do the 3 and 6 first because they're on that circuit going.
That's right. Yeah, so the 3 and the 6 here, there's no breaks in the circuit, or no junctions in between them. So I know that these are series or parallel?
They're series.
Those are series, right. And a 3 and a 6 in series is equal to what?
2, right?
Right, the 2.
Because that would be 1/2, and then 1 over 1, or 1 over 1/2 is 2.
That's right. So I'm left with a 2 microfarad capacitor and a 4 microfarad capacitor. 12 volts. And then I'm mostly done. Like if I want to find the voltage here, what is it? The voltage.
Voltage
For-
is
For capacitors in parallel, they all have the same voltage. That's the same as for resistors. And so for this capacitor, this 4 microfarad capacitor, it has what voltage? 12 volts, right? Because both of these actually have 12 volts. So this one has 12 and this one has 12. And then I come over here, and I know that these are going to have 8 and 4 because one of them's twice the other, and so one of them has to have twice the voltage. So which one will have the 8 volts, the 3 or the 6?
the 3.
The 3. The smaller capacitor will have the larger voltage because there's this inverse relationship between C and B. If C goes up, B goes down, and vice versa. So I have 8 volts, 4 volts, and 12 volts on those capacitors. Right, so 8 volts, 4 volts, and 12 volts on these capacitors. And then I can also find what is the charge. If I know 2 quantities, I can find the charges on them. So I could say 24 microcoulombs. I'm just doing Q equals CV. This likewise is 24 microcoulombs. That's a good thing, right? Because capacitors in series have the same charge. Capacitors in parallel have the same voltage, but capacitors in series have the same charge. And then that's it. That's all the answers. Actually, here I have also 48 microcoulombs, just doing Q equals C times V. All right. I could also ask in this on a test, I might have a string of questions about it. And so, for example, I might also ask, what's the energy contained in one of these capacitors? And that's just our 1/2 CV squared. So if I wanted to know, say, the energy from here, I would just say 1/2 of 3 times 8 squared. That energy 1/2 CV squared, we did that in class. 1/2 of 3 times 8 squared, that's 432, 96 microjoules. All right, so you also need to know how to do that. So let's say, for example, I want to know the energy. It's equal to 1/2 CV squared. That's 1/2 of 3 microfarads times 8 volts squared, which is, what did I say, 96? 96 microjoules. Let's do a resistor problem. Can we switch back and forth? Is that okay? I want to do a resistor problem because I was doing this with some students the other day, and I think you'll likely see a problem like this. And this will help you to think about these resistor problems. It'll also help you to think about the capacitor problems because you approach them in much the same way. It's just the rules are a little bit different. All right, so let's say that I have a circuit with resistors.
let's say that I have 2 ohms, 4 ohms here, and 2 and 4. 8 volts here, and I want to know what is this voltage. All right, can you tell me what the voltage is on the battery? It's a little bit different than we've been doing. If I had 2 ohms and 4 ohms in series, we'll come back to that other resistor in just a second. And I want to know what is the voltage on the battery. How would we go about that?
Finding REQ first?
No, you don't really need to find REQ. Now, let's go over sort of some of the things that I know. I know that whatever current I have here, I'm also going to have here, right? I also know that whatever voltage I have in these parallel parts of the circuit, either the voltage in this part or the voltage in this part, that's going to be equal to the voltage in the battery. All right, so what is my current in this part of the circuit? Remember, current is voltage over resistance, so that current is going to be
It's 8/6, right?
well, this is 8/6. No, I have 8 volts across this resistor. So what's my current through this resistor right here?
That'd be 2, right?
I'm going to have 8/4, which is going to be 2 amps.
Okay.
So I have 2 amps flowing through this resistor, but because these two are in series, I'm also going to have 2 amps here. Right? So if I have 2 amps here, I have 2 amps here, that means my voltage here is 8 volts, right? I know that. What's my voltage here if I have 2 amps? 4 volts. So what's my voltage here? 12, right? So the way you do this, sort of stepping backwards, you would say, well, I know that my current here is V over R. That's 8/4. That's equal to 2 amps. All right. I also know then, if that's 2 amps, then I also have 2 amps here. And then I can find my voltage here, which is V equals I times R. That's 2 times 2. That's 4 volts. So these combined will give me 4 plus 8. So this is equal to 4 plus 8, which is equal to 12 volts. Right. Likewise, I'm going to have 12 volts over here. So let's say that my current here is 3 amps. What is that resistance in the other part of the circuit? What's this resistance? If you measure your current here to be 3 amps, what's this? Right, this is 4. This has to be 4 ohms times 3 is equal to 12. You can see some questions like that. I'm pretty sure you will see questions like that, where you have to step backwards and figure out some of the things. You want to do another one?
Yeah, sure.
Okay. It's a little bit different than we've been doing. I think we're going to do some sample problems next time in class. We will. Let's say that battery no, let's not do this. I'm sorry. We'll do, sorry guys. Do 3 ohms there. Yeah, and then I'll do 2 ohms here and here. And let's say I have 4 amps here, and
and 12 volts here. Let me make sure that's going to work out right. I want to know that unknown resistor. Hold on, let me just check it there. Yeah, that'll work. So what's that unknown resistor is the question. If I have this circuit,
So we're looking for that one in series with 4 ohms.
right, I'm looking for that one that's in series with the 4 ohms. All right? So if I have 4 amps there,
And we know that coming around, so around it should be 4 amps from those 4 resistors because that's being put in.
right, yeah. So I have 4 amps in this circuit throughout this part of the circuit, and then also throughout this part of the circuit. So your first step, let's think about this. I want to find what is the equivalent resistance of this. 1 over 2 plus 1 over 2. So the equivalent resistance of this is just 1 ohm. So if I have 1 ohm there, what is my voltage across that part of the circuit? If I have 1 ohm, equivalent 4 amps, I'm going to...
It's just 4 volts.
4 volts, right. So I'm going to have 4 volts across that part of the circuit. So I have 4 volts here. What then is the voltage across this part of the circuit? If I have 4 volts here, that's right, I'm going to have 8 volts across that part of the circuit. You see, I have 2 parts of the circuit that are in series with one another. It's pretty good, actually. And then I'll have 8 volts and then 4 volts. Okay? So if I have 8 volts there, let's see how I can do this. That means that the equivalent of this branch of the circuit is what? I have 1 voltage that's twice the voltage over here. So what is my equivalent of this part of the circuit going to be? That's a good question. I should write this down and put on the graph.
This is a tough one.
Yeah, this one's kind of tough. All right. So what is the equivalent of that? Let me redraw it a little bit. So what we're doing here is we have a 12-volt battery. I have 2 resistors. One of them is a 1 ohm, and then one of them is a unknown resistor. But I know that I have 4 volts here, and I know that I have 8 volts here. What is that unknown resistor that has 8 volts? And I know too that I have 4 amps that's coming through the circuit. So if I have 4 amps coming through this circuit, what is that unknown resistor? It's going to be 2 ohms. So I have 2 ohms here. I can look at that in a couple ways. I can say, well, R is what? V over I. That's going to be 8 over 4 is equal to 2. Or I can look at it sort of holistically, look at the whole thing, and say, well, this has twice the voltage as this, so this has twice the resistance of this. So that means this has to be 2 ohms.
So it's just a direct relationship.
All right, so I have 2 ohms. Yeah, it's a direct linear relationship. That's unlike the capacitors, where it was an inverse linear relationship. Okay, so now going back, I know that I have to find this to give me 2 ohms equivalent resistance. What does that unknown resistor next to the 4 ohm have to be in order to give me 2 ohms? Well, I know this bottom part has to be 3. What paired with a 3 ohm resistor will give me a 2 ohm resistor equivalent? 3 and what makes a 2 ohm equivalent? It's 6, right. So this top one has to be 6. So what is this? That's right. Does that seem difficult? We're going to spend some more time on it.
I think that, like, I was intimidated by it, but, like, when you started breaking it down, then it was like...
Yeah, you know how to do it. It's just sort of got to get started on it. We'll do another one.
Refresh me real quick. It's in series. You add them, but in parallel, it's more the 1 over 1 over.
That's right. I'm going to recap the rules here in just a second. So I know that. Let's see that this whole thing has to be 2 ohms, and a 6 ohm and a 3 ohm together in parallel will give me a 2 ohm. That means that this one has to be 2 ohms, because 4 plus 2 equals 6. All right? We'll do another? Yeah, let me recap those rules though first, just to remind you. So these are for resistors. for resistors in series, the equivalent equals R1 plus R2 plus dot dot dot. That's the first rule. The second rule is, shoot, what is the second rule?
I have them written down. Like
No, it'll come to me in just a second. It's just, I usually shut down after about 11 o'clock.
Yeah.
All right, I sort of stopped thinking,
I agree.
yeah. What is this? Right. Oh, they have the same current. Resistors in series have the same current. Also, resistors in series, V equals IR. That's true for all resistors. And then the fourth one for resistors in series, V is equal to V1 plus V2 plus da da da. All right, for parallel, resistors in parallel have the equivalent is equal to 1 over R1 plus 1 over R2 plus however many resistors you have. Oh, see, that's rule number 1. Rule number 2 is they have the same voltage. Rule number 3 is V equals IR. And rule number 4 is that I total equals I1 plus I2 plus dot dot dot. And then let me remind y'all again of those relationships, the math relationships, because it'll really help you when you're looking at these circuits that you just got those numbers really quickly. So I gave this to you in class today. Let me just remind you. If I have a 3 and a 6, 1 over 3 plus 1 over 6, that's equal to 2. If I have a 4 and a 4, that's equal to 2. Isn't that right? Yeah, if I have a half, a 2 and a 2, that's equal to 1. If I have 3 3s, that's also 1. And what was the other one? 2, 4, and 6? Is that right? 2, 6, 6. No, 2,
No,
3, and 6.
2, 3, and 6.
Yeah, 1 over 2 plus 1 over 3 plus 1 over 6. Common denominator is 12. That's 6 plus 4 plus 2. Yeah, so that's 1 over 12 twelfths, which is 1. So it'll help you to just know those numbers, sort of have them on the tip of your tongue. All right, let's do another problem. Let's just give you a circuit. Oh, yeah. Okay. If the equivalent resistance of this circuit is equal to 2, what is the unknown resistance? If the equivalent resistance of this circuit is equal to 2, what is the unknown resistor?
It's on the one in series first, which is 4 ohms. So those top 2 resistors in series, that's equal to 4 ohms.
Wait, hold on, let me rethink this. I'll make sure this is working out right. Now let's make this a 1 ohm right here. So what is the equivalent resistance of this circuit? Or what is the unknown resistor? So what I have here is I have one resistor in series with another resistor that's made up of these 3. All right, a 4 and a what I know in series. I want you to know I can't do that. It's all right. Let's go back. So I'm trying to come up with these on the fly. Let's say this is 2 ohms, and instead of 2 ohms here, this is 6 ohms. So now what is the unknown resistance?
So that would be 4 ohms, and that whole thing's in series, so we have to have something, that whole thing would have to be 2 ohms.
Right, so this whole thing has to equal 2 ohms. All right.
And so what in parallel with a 4 ohm can give us 2 ohms? So that'd be that'd be 4 ohms?
The unknown?
Yes.
That's right. Yeah, so I have, if I have 2 4-ohm resistors in parallel, that gives me 2 ohms, right? 1 over a fourth plus a fourth? Okay, yeah, so the right answer here is, yeah, what did we say it was? 4 ohms, right. So that's 4 ohms. Now let's just do a quick problem. So let's say I have 12 volts down here. What is the voltage and or the current on all these things? Well, I know the current in the 4 ohm resistor right off, right?
Yes.
What is it then? No, not 3. Think again, because the current that comes off of this battery is the current that goes to the equivalent resistor. 2 amps, right. I'm going to have going through this resistor 2 amps, because whatever goes through this resistor goes through the equivalent resistor.
Okay.
Because all this stuff right here is equivalent to 6 ohms. So I have 2 amps going here. So what is my voltage here? Well, I have 2 amps here, right? Y'all just said that.
So 8
volts. Right, 8. So let me write that down. So here the current, I know that the current coming through here is 2 amps. That means here I'm going to have V equals IR. That's going to be 2 amps times 4 ohms, which is equal to 8 volts. All right? Now what is going to be my voltage across this resistor right here? If I have 8 volts here, what do I have for this resistor? What do you see? 4s, right. Because this is in parallel with this, so these 2 resistors have the same voltage as this resistor. Right, so this is going to have 4 volts. Let me redraw it. Let me redraw it so maybe I'll make sure it's clear. So I can redraw this whole circuit. Right. So this is 12 volts. These are the same circuits. I have 8 volts here. I also have 12 minus 8 equals to 4 volts across both of these branches. This whole thing between this point and this point has 4 volts across it. And both of these have the same voltage, so I have 4 volts here, and I have 4 volts across these 2 resistors. So this resistor then has what voltage? It has 2 volts. And this resistor has 2 volts. And this resistor has what current? No. 1. It has 1. I is equal to V over R. Okay? Right, yeah, you multiply and set it up. So 2 over 2, I have 1 amp each here and here. What is my current through this resistor?
1/2.
Okay, well I have 4 volts and 4 ohms.
Oh, still.
It's going to be 1 amp, right? So I have 1 amp here, 1 amp here. It's a good thing because look, I have 2 amps here, so that 2 amps here splits into 1 amp and 1 amp.
Okay.
All right? Let's see. Well, next week we're going to spend some more time on this because we're going to have a little bit of downtime because we're not going to go through all of chapter 4. So we'll spend some more time practicing this. Let's see. Anything else in particular? Or we'll do some more, but anything in particular that you want to go over? Okay.
I like the switch thing in the tech concept test. The switches, the lights, like A and B. Because whenever I was taking the quiz, I didn't get it. I was like, what the heck? And then today in class we had the same thing, and I was like,
Yeah. Okay. Right.
I was like, okay, I like it.
Yeah.
I get it now.
All right. You want to look at some old test questions?
Sure.
All right. I think most of these are exam 2, so. I don't know. That's S11. Let's look at exam 1, S11. Let's do some capacitor problems and some resistor problems. All right, so consider this circuit. What is the charge on the 3 microfarad capacitor? By the way, this is exam 1 of spring 11, if you're following along. So I want to know, what is the charge on the 3 microfarad capacitor? Okay, so don't forget your rules for capacitors. Capacitors in series have the same charge. The equivalent capacitance is that 1 over 1 over business. Q equals CV, and then capacitors in parallel have the same voltage. The equivalent is just the sum, and Q equals CV.
Just opposite of resistors.
Right, for the equivalent. But the other rules, like the voltage adds up, is still the same. So for like capacitors in series, I know the 2 voltages here have to add up to equal 12 volts. All right. So if I want to know the charge on this capacitor, I want to ask myself the question is, what is the well, I can do this a couple different ways. What is the voltage distribution on these 2 capacitors? I have one capacitor that's half the capacitance of the other. And I know that they have to add up to equal 12, because I know I have 12 volts and 12 volts. So this one being the smaller capacitor, is it going to have the bigger or the smaller voltage? It's going to be the bigger. Since Q is equal to CV, if C goes up, B goes down, or vice versa. If C goes down, B goes up. They're inversely related. So I know that these 2 numbers have to add up equal to 12, and one is twice as big as the other. So that puts this voltage at 8 volts, and this one at 4 volts. And I want to know the charge here. Q is equal to CV. So what's my charge here? We just said it has 8 volts, 24 microcoulombs. So the answer is B, 24 microcoulombs. The other way that you could do that is you could say a 3 and a 6, that's an equivalent of not 9, but what? Yeah, 1 over 3 plus 1 over 2. 2. Right, so that's an equivalent of 2 microfarads, and that equivalent charge will be Q is equal to CV. Let me write this down. So this is an equivalent. The equivalent capacitance is equal to 2 microfarads. And so the charge on that equivalent capacitance times V is going to be 2 times 12. So that's going to be 24 microcoulombs. That's the same as the answer we just got doing that other method where we looked at the distribution of the voltages. And this is true because capacitors in series have the same what? Charge, right? Capacitors in series have the same charge. Capacitors in parallel have the same voltage. These 2 capacitors have exactly the same charge. What's this charge? 2 times 12, 24. This charge is 24 because it has 12 volts, also 24. All right. Yeah, that was the next question, 19. All right, let's go to exam 2, spring 11. This is exam 2 of spring 11. Listen, guys, if you're going through old tests, we're not going to get to multi-loop circuits. So whenever you see a circuit that looks like this, you'll know it because it'll have multiple batteries in it. Okay. We're not going to get into that. We'll save that for the next exam.
I don't even know how to do that.
Yeah. Well, let's try this one. All right, this one looks complicated, but it's not terribly complicated. I want to know what is the equivalent of this. You're about to say it. What are you going to say?
If there's 4 ohms.
4 ohms total. You say just kidding?
So 4/3?
No. I mean, that's not your answer. It's either 1, 7, I guess 1.4 is almost 4/3 or 4, but it's not 4/3. Oh, you start with the smallest part first, right? The 1 and the 1 is what?
That's 2.
Right. The 2 and the 2 is what?
Oh, that's what. That's 1.
1. So I have, and then another 1. So I have 2 down here, and I have 2 up here. A 2 and a 2 in parallel. That's what? 1. Yeah.
I didn't know all of them.
On your test, you'll be able to write it.
Yeah,
So.
for some reason I added that R5 with the R1 and 2. For some
Right. Okay. So this is 2 ohms.
Yeah.
Right. This is 1 ohm. All right, and then combining these two gives me 2 ohms. So that's 2 2-ohm resistors, or 2 ohm in parallel with another 2 ohm. That's 1 over a half plus a half, which is 1. Right, so the answer is 1. And then what is the potential across R3? Erase all this. You'll start thinking about it.
Voltage, right?
Right. Potential is just another way of saying voltage. I want to know what is the potential across R3. You think about it for just a second. What do you? No.
Okay, so you said resistors are parallel, share the same voltage, right?
That's right. All right. Now, don't forget, I have 12 volts here across these two. So, like, if I were to ask you what is the voltage here, what's that? That's 6, and this has 6. So these two have 6. And then you want to ask, you want to tell yourself, well, these two also have the same voltage, and their voltage is the same as their equivalent resistor. These two have an equivalent that's equal to what? A 2 and a 2.
Oh my
1,
God, that's true.
right?
Thinking of capacitors.
So I can replace this with a 1 ohm resistor. So I have a 1 and a 1 in series. So what's the voltage across this 1 ohm resistor?
It's 6.
6.
So
Right.
divide it into 2, so they're both 3.
No.
Oh,
Don't, because,
That's wrong.
yeah, that's what you did.
Yeah, okay.
Yeah, and that was an answer. Like on the next question, that's kind of off. Okay, so be careful. I'll have 6 on
But it would
both
be
of
6
them.
and 6 because
Right. So I have 6 volts here, 6 volts here. In fact, I have 6 volts on every single one of these. Alright? Because here I have 6 volts because they're splitting 12 volts.
Yeah.
Here I have 6 volts because it's splitting 12 volts with another 1 ohm resistor. And here I have 6 volts because the 1 ohm resistor, the equivalent, has 6 volts. And they both get 6 volts because they're in parallel. Because resistors in parallel have the same effect. Yeah, it's a little tricky. Or not tricky, just
yeah.
all right. I'm gonna have to leave about a quarter of. Okay. But so we'll just do a few more if that's okay. Oh, which has the least current flowing through it? I'm going to give you several options. Let's see, which has the least current? Is it this one, or this one? Which of these has the least amount of current flowing through it? R3 does, right. You know what that current is? What was the answer to this question number 3, first of all? Let's see. It was 1 ohm, right? So if I have 1 ohm of resistance, what is my current flowing here? Off of this 12-volt battery into a 1 ohm resistor right here? I have how many amps? 12 amps. I have 12 amps of current. That 12 amps comes up here and it splits into what and what?
6 and 6.
It splits into identical amounts because I had 2 ohms up here and 2 ohms up here. So I have 6 amps and 6 amps going through these resistors. And what current do I get here?
3 amps.
I get 3 amps. It splits again, 3 and 3, and then it comes back together, and I get 6 here. So if I go think about my currents, I have 6 amps, 6 amps, 3 amps, 3 amps, 6 amps, and 12 amps total. Right. Okay, let's see. Okay. Let's bring 12. Alright, let's think about this one. What's the current through this 1 ohm resistor?
So that would be 12 amps. If I'm right.
No, that's not right.
Oh, it's not even a good choice.
Yeah, so first of all, you want to ask yourself, what is the equivalent resistance? So I want to know first, what is the, I'm going to ask now, what is the current through this resistor? But then also think about what is the current through this resistor. What do you think of? Why do you think it's 6?
It's 1 over 2, 1 over 2.
Because you have a total of 2 ohms.
Right.
2 ohms divided by 12, it's 6 amps.
That's right. All right, so I have a 2 and a 2, which is 1, right? 1 over a half plus a half is 1. And then I add it to this one, so it's 2, right? So that means I have 6 amps coming off of here. That's 6 amps here. What's my current here? 3, because it splits evenly. I get 2 and 2 gives me, I get 3 amps and 3 amps. It splits that 6 amps. So I have 6 amps, 3 amps, 3 amps. My voltage here is what?
12 volts.
I have 12 volts here. It has to be something less than 12. Well, let's go back and think about what are these two combined? They're a 1, right? That's what
Oh,
this
so
is.
it'll
1.
be 6.
Right. So I'm going to have 6 volts and 6 volts.
Okay.
You know, on the test, like, you'll be able to write these things out.
Yeah.
But it's useful just to be able to look at it, think about it in your head. It makes things a lot faster. It makes it a lot easier for you.
I have a question on current. Say those 2 amps in parallel, or those 2 resistors in parallel. What if like the top one was 3 ohms and the bottom was 2? Would that affect the current?
Yeah, it would affect it. You would get more current. So let's, instead of saying that, let's say that, let's say that this is 2 ohms, 3 ohms, 6 ohms, right? And then that affects the total, right? Because that gives me a 4 ohm equivalent, which gives me 3 amps here. All right? Because 6 and a 3 together gives me 2, right? And then 2 and 2 gives me 4. So as my current travels through this circuit, I get 3 amps here, and then it splits into 2 pieces. And one of them will get a bigger current, and one of them get a smaller current. Because they're different by a factor of 2, one of them is going to get twice the current of the other. So in this case, 2 numbers, one of which is twice the other, that adds up to 3 is what? 2 and 1. So one of them's going to get 2 amps.
2 amps.
So what now?
The 3 ohm one's going to get 2 amps?
Right, because it has less resistance. It doesn't resist the flow of electricity as much, so it's going to get a bigger current. This is different from capacitors. For capacitors, the voltage was inversely proportional. Well, we're talking about current here. But yeah, the smaller resistor, forget what I said about that. The smaller resistor gets the bigger current.
Yeah.
Okay? So I'm going to get 2 amps here and 1 amp here. Now, if you want to do that a little more rigorously, you would say, well, I'm going to draw my circuit. I have a 2 ohm and a 2 ohm. I get then a 4 ohm equivalent on a 12 volt battery. That gives me 3 amps of current. But if I have 3 amps of current, that means I have 6 volts here and 6 volts here, right? Because 2 times 3 is equal to 6. And if I have 6 volts here, that means I have 6 volts here and here. And then I is just V over R, which is 6 over 3, which is equal to 2 amps, which is what we found. This is 6 over 6, which is equal to 1 amp. All right, you can go through it in that way, but takes a little bit more time for you to do it that way.
Okay.
All right, I'm gonna have to cut us off there. I'm sorry.
It's fine.
But we'll meet again next time on Thursday. Sorry.
Not bad at all.
We're gonna spend more time in class on this.